Okay. Okay. I don't think I have anything. Oh, okay. Now I have this. But okay. Let me okay, so I'll use my name as Blame. Okay. Jesus called Festival of Black Holes. Yeah, I forgot to put a picture of a black hole because I was busy with stuff, but I'll look for let me look for a picture of a black hole. Okay. Nah, I actually misspelled it because so today I'm trying to show you this. A black hole. There's a Bible stating the existence of black holes. You know, now, let me tell you something. Okay, well, I'll go and download black hole and click save. So that's a picture of a black hole. Well, yeah, kind of. Here's another picture of a black hole. There's another picture of a black hole. So now I know about these atheists. They like to talk about black holes. Now you may be thinking, right? First of all, black holes. Well, first of all, I know a black hole is a star that collapses on itself. You know, so yeah, I do believe they're real, and I think so. And I know so it's other things. I'll get into white holes and white dwarf and black dwarf stars pretty soon, but and I'll also get into neutron stars pretty soon too. But I want to talk about black holes first because I also want to get into monopoles sometime too. But right now I'm getting to black holes. So and I know that and I've been learning about the problem is that and about black, the color black. Yeah, I know, and I've been learning about the color black and stuff, and I heard that the Chinese people and now the people in China right now. Well, I learned that a few of them are painting pigs black, which is not good because that's going to affect our food supply. But anyway, I know that's not good. I know that was from Winston, from his YouTube channel called Sorbets, but I know. You can learn more about that anyway if you're interested into China. But anyway, like me. But anyway, I'm talking about black holes. So because black holes is something about outer space and stuff. Okay, so today I'm going to talk about black holes. But first I want to talk about black holes in other languages. Oh, and do I have, yeah, I can have it right here. So black hole. I'll get into what other ones are in other languages later, but first I want to dig into black hole. Okay, let's get into black holes. Yeah, this is the word black hole, and I want to show you what it says in other languages before I continue with the R's. So black hole.
Agujero negro.
Agujero negro is black hole in Spanish. No, I didn't. Okay, no, I forgot to type it for French. But let me fix that. I'll go to Google Translate, and I'll do it for you. Okay, now I have black hole in French.
Trou noir.
It's true noir. Okay, now we can get into black hole in Mandarin.
Hey dog.
Yeah, hey dog.
الثقب الأسود.
Well, it's Wano. Yeah, that's black hole in Arabic. Yeah. Anyway, here it is. If you're interested into this one, Japanese, here it is.
ブラックホール。
Barakahoru is black hole in Japanese. Okay, and then one more to maybe understand this language. Yeah, Korean. Black hole. Okay, it's black hole in Korean. Okay, and that's it. Okay, that's languages I'm just going to show you because. So here, the first photo ever. So the first ever photo of a black hole. In April 10, 2010, the Antimas Chalmers revealed the first ever photograph of a black hole. Modern physics sees time of the United States integratic, forming a fabric membrane called space-time. A black hole's region is space-time extremely distorted, and space-time of dense mass. The gravity region is so strong, anything too close to the black hole would never escape. Some black holes have masses comparable to that of our sun. These stellar mass black holes are thought to form when a star consumes and its last nuclear fuel collapses under the influence of its own gravity. Other supermassive black holes are thought to have masses millions or even billions or times greater than this. These supermassive black holes seem to be present at the center of most, if not all, large galaxies, including our own Milky Way. This particular black hole is a supergiant black hole with an estimated mass 5 billion times greater than our sun. It is located in a supergiant elliptical gravity with M87 about 5 million light years from Earth. Scientists have long speculated on the possible existence on such objects, and there is much evidence for their existence. However, this is the first time that a black hole has been imaged directly. Or at least somewhat directly. The black hole itself can't really be photographed because its gravity is so strong that any light emitted from within the black hole's edge, a spherical boundary called its event horizon, literally cannot escape. Rather, the image shows a glowing disk of gas surrounding the black hole's shadow. The surrounding disk of gas has been swept up by the black hole's strong gravity. Scientists perform this very impressive technical achievement by using a network of 8 radio telescopes around the world called the Event Horizon Telescope. Does this any relevance for creation? Due to part of the weird nature of black holes, some creation supporters have questioned whether they are real. We have every reason to think that they are. Einstein's theory that gravity makes very accurate predictions about the behavior, and stated earlier that there is much direct and now direct evidence of their existence. Now, the image agrees very well with predictions of Einstein's theory of general relativity. As a side, many creation researchers think that Einstein's theory helped explain now how the distant starlight in a young universe. Okay. Finally, we have it's worth nothing that supermassive black holes has such a photograph present big problems with Big Bang scientists. Some of these giant black holes have been distant of enormous distances from us. In Big Bang thinking, this means that we are saying these giant objects are not as now, but as they were shortly after the Big Bang. The most extreme example that this is a giant black hole that have formed just 690 million years after the Big Bang. Yet these secular scientists are puzzled to how natural processes could form such mentioned objects so relatively quickly. This is a very similar problem with mature distant galaxies, also Planck's Big Bang model. That goes so weird because God's work is a timeless reference for our Creator. Okay, well, I can't find that one, okay? Anyway, this is in Genesis, so. This one's called, A Picture is Worth 1,000 Words. The first one of black hole is a disk around the black hole. How biblical creationists sometimes understand black holes. Many people asked me in 2019 to ask for the first photograph of a black hole. The main question is, has Ben Howland been taking a photograph? Not it doesn't give off the light. Indeed, has been a sort of question about black holes. I have been asked many times over the years. If we can't see them, how do you know that they exist? I suppose if you genuinely believe in many things we don't see, electrons, air, wind, quickly come to mind. When we can't see these things, there are abundant evidence of the existence of observable effect that they have on other things. The same is true of black holes. In the presentation they give titled "Things That Go Bump in the Night," also available on DVD. This is a talk about dark matter and dark energy too, but I spent the first time presentation talking about black holes. Seeing is impossible. So how do we detect black holes? By the effect of its gravity on nearby objects. For instance, as matter falls toward the black hole, the mass flattens an orbiting disk, friction or is a metal energy crossing the matter to the black hole. Paradoxically, the orbital speed increases as the matter falls inward. The energy has lost to friction, transformed into the heat of temperature of millions of degrees. One way to detect black holes is by observation of X-rays from the hot inner portion of the disks. X-rays are difficult to produce copious amounts, so X-rays are the type of relativity of the spot. So measures of the speed allows astronomers to compute the mass of the black hole. Astronomers have been detected black holes this way for half a century. The first photograph of a black hole wasn't a photograph of a black hole, but rather an accretion disk around the black hole, since a sort of a matter of a disk and falling. We call this disk around black holes the accretion disks. The accretion disks are stellar-sized black hole. Black holes relatively small. Hence, at distances we observe black holes and accretion disks and stellar-sized black holes with too small image. What astronomers have nearly much larger accretion disks, but around the monster supermassive black holes that reside in the center of most gravity. For this study, astronomers estimated that the black hole at the center of M87, giant molecular gravity, about 55 million light years away, and the mass of a black hole about 7 billion times of the mass of the sun. It's correct. Even Horizon Telescope calibration. However, the problem is with accretion disks is much better, of course, the gravity surrounding the massive black holes into the air with the light coming from the accretion disks. To get around the problem, the astronomers observed the wavelength of 1.3 millimeters, a portion of the radio spectrum, largely unaffected by the electromagnetic matter. But then the problem arises. Due to the long wavelengths, radio waves yield a very poor resolution, resulting fuzzy images. To circumvent this problem, the radio astronomers combined data from several widely spread radio telescopes. This technique is called Very Long Baseline Interferometry, or VLBI. While VLBI has been around for decades, the very important improvements in computer technology have been made at high resolution possible. The Sunday question used 8 radio telescopes around the world in the system called the Event Horizon Telescope. Given the wavelength observation configuration of radio telescopes and resolution, this project 25 millionths of an air second. Distance of the M87 corresponds to 400 astronomical units. The extra AU is the distance between the Earth and the Sun, roughly 150 million kilometers, 93 million miles, and is something about as 400 times larger than the Earth's orbital radius would show up. The accretion disk was also supposed to be lighter than this. It ought to show up as in the radio image. This is awesome image worthy of note, but press the counts would have been a bit misleading. As we can see in the image, accretion disk shows up as a ring. And this is tempting to think that a dark spot in the middle is a black hole. However, this dark spot is 2.6 times the size of a black hole. This dark spot is compared to a shadow of a black hole. The light is coming from the region within the dark spot, but the outside of the black hole is trending a bit out of our line, sending up the black hole's gravity. That is an awesome image of worthy note, but it perhaps have been misleading. After all, since photographs images of light, as in the case of radio emission, and black holes give off no light, and we can't directly photograph a black hole. We can see a shadow of a black hole here. Thus, at first, photograph is big news. Coming soon, black hole near you. An extended image of supermassive black hole, the center of our own gravity, to be announced soon. The same team observed goings on in the center of the Milky Way. Milky Way black hole is less impressive, only about 4 million times the mass of the Sun, or about 1,000th of the mass of the black hole at the center of M87. But our black hole is much closer, 25,000 light years as our past, to the 55 million light years, or 1/1000 the distance, so its accretion disk ought to be valuable. Now, in the conclusion, what does this all mean in regards to evolution and creation? Probably not much. My founding creationists are literally black holes, sedition fueled by digressions of segregation about their origin. However, the second case we made a mixture of black holes, apart from the idea of came it to be. The rest of the black holes are very cool of God's creation. But how do stars collide this up to a black hole? You remember me asking, right? Well, probably a star that's probably a hyper giant star. I know. I think when a star when a star becomes a hypergiant and explodes into a hypernova, that's when it turns into a black hole. That's when it starts turning into a black hole. You know. We got more anyway. We got more articles to read anyway. So let's read more about this one. So you can learn more about black holes. Okay? Yeah, you know. So black holes. Not seeing is not believing. Well, first of all, seeing is not believing anyway, so what's the point anyway? I understand many years ago, Superman comic books ran a story in which Superman flew faster than the speed of light. Well, reader to the Dear Editor column claimed according to Einstein's theory of faster than light travel, it was impossible. An editor, writer of what Einstein was in theory. What Superman flies in is fact. Now there was a news report that Laura Mystery Huntington, University of North Carolina physicist, has published a paper which she concluded that stellar black holes do not exist. More specifically, she said there is a problem with the theory of stellar black holes come to be. Supposedly, a stellar black hole comes to when a core of a massive star implodes, producing a type of supernova. Many often have concluded the process not enough matter remains the core to form a black hole. And this comes after Stephen Hawking's conclusion earlier. You know that black holes that do not exist, and coming from Hawking, because it's continued to our understanding of black holes than anyone else. What Hawking, Miss Sunny Rafton was in its theory. What black holes do is fact. I know, because I know named after yeah, I know they call it Hawking radiation, those black holes, but first of all, Hawking radiation is just something that's just made up. I know, I think by Stephen Hawking. And now, don't get me wrong, I mean no respect toward these two scientists. I think we have our own theory about digging too much what they believe. The two pillars of modern physics are quantum mechanics and general relativity. Quantum mechanics, the study of very small systems and atoms of atomic particles. General relativity is the best theory of gravity, space, and time we have, and applies to very massive systems. Applies these two theories are more different, and these are different apply. Very different, so it's no overlap. However, this makes a patchwork over the world, and sometimes have no ought. The single unified indeed. These indeed physicists have been looking unified since the world since before I was born. Black holes push neutrality from back the ability to explain the world. Black holes amount to a singularity, something that is not mathematically defined. Hence, general relativity breaks down within a black hole. Fortunately, years ago, Hawking has shown an event horizon surrounds a black hole. The event horizon is sort of screen shields us the mathematical ugliness of a singularity. Explain how Hawking has decided the event horizons don't exist, which is the reason why has backed away as some of his earlier work. The fact is singularities arise in ignition of general relativity is an incomplete theory. That there is probably theory beyond the relativity that solves the singularity. The problem with that includes general relativity, a special case. Another problem that is that black hole domain where both quantum mechanics and general relativity overlap, because quantum effects begin to show up in black holes. For instance, if a particle falls into a black hole, it could take information of quantum mechanics, what it says, and it'd still be available in the rest of the universe. But that information is not available once it falls into a black hole. There is a patchwork approach that gets into trouble, but quantum mechanics gravity could solve these problems, but no such theory yet exists. Back to the work of Mr. Houghton. In work it's difficult to explain the origin of black holes. Many people, including creationists, have the origin of black holes as with the science of black holes, an idea about black holes. There's very good assistance that black holes exist, but this is experimental observational science. The question of where black holes come from is a totally different issue. Experimental scientists cannot address. Other scientists have ideas upon science we can explain such things but there is no way to test ideas because it happens in the past. This is historical science about creation scientists. I have no problem with God miraculously making black holes during the creation week, nor do I have a problem with black holes forming today through natural processes that God has ordained. I seriously doubt that there's no study will astronomers give up black holes. And we have abundant idea of black holes. We have to explain it by other means abundant of evidence to store black holes, supermassive black holes, lurking in the cores of galaxies. By the way, and while there is a standard theory of stellar black holes might form, there's no agreed upon theory how these supermassive black holes in the cores of galaxy formed. But astronomers don't doubt that they exist. Now, black holes. Real or imaginary? The problem is overall and versus historical science. So black holes form a background in many science fiction stories, but black holes are not fictional. A black hole is probably supermassive and dense, a light that cannot escape from enormous gravity, and so it is invisible even. We cannot see black holes. The way we see a star or a moon, there is overwhelming observable evidence that they do exist. Astronomers must see effects of enormous gravity and other things in space. So if the case that the secular scientists now claim that black holes may not even exist, but both Dr. Stephen Hawking, the scientist from the University of North Carolina, have promised that black holes, and these understand, they are as really here. As our Genesis astronomer Dr. Danny Faulkner explains that in the book of last week, the most difficulty lies in our complete understanding of physics. I've explained the nature of a manner of energy, great and small. But the root of the problem is he says, the confusion of observable and historical science. The scientist in North Carolina does not believe that stored black holes could form the way they believe they formed. Therefore, she promises they do not exist. We cannot observe the historical origins of a black hole. Actually, we cannot know how they formed, but it does not change the fact that they exist. Astronomers like Dr. Faulkner, the primary research concerns binary stars that tell us that stellar black holes could be part of the binary star systems, and the presence of though unseen, explain the behavior of companion stars. Unseen black holes, the center of the galaxies, would explain observable behavior and objects of the gases near of the various galaxies. Even though the laws of physics presently understood the struggle to explain what is going in a black hole, and he formed astronomers that can know a black hole form on observable way affect other things. Danny Faulkner explains to this blog. Many people, including creationists, confuse the origin of black holes with the science of black holes. As I showed in a DVD about black holes, there's a very existence that black holes exist. Experimental observational science, and where the question of black holes come from, entirely different issue that experimental observational science cannot address. Rather than science develop ideas, what science explain how such things come about, we have no different idea of these ideas, because it happened in the past. This is historical science. The creation scientists have no problem that God miraculously making black holes during the creation week, nor do they have a problem with black holes today, natural processes that God has ordained. Okay. Now, evolutionists believe that evolution must have happened because life exists, and they could have existence, and they could have existed in no other way. Perhaps subjecting of black holes can help understand that as evolution, the existence and observable behavior, understanding that does not reveal observed untestable origin and untestable past, observable past. It's quite ironic. Secular scientists can observe how life supposedly formed from non-life natural processes that supposedly evolved over millions of years, yet they believe it happened, and propose a story of how they think it happened. However, the scientists quoted above, can't see how black hole formed and see how propose denying their existence. Yes, Dr. Faulkner is right that these scientists don't understand the difference between observable science and historical science. This is why he emphasized the important teaching. My recent debate with Bill Nye, the science guy, of course, if he left research like Nye admitted that molecules demand evolution was in the realm of historical science, they would have to admit that they hold beliefs. These secular scientists do not want this conclusion. They want to keep doctoring the generations of people to believe molecules demand evolution is fact. If you read Dr. Devore's blog, you have informed that in the course of your conversation of black holes with your friends, as your review of Instant Guide for Cosmos, the sky of ghosts, and all explores the nature of black holes. Okay, and so I'm going to open this DVD. Let's go over that. Links of black holes, dark matter, and dark energy fit into the universe God created. Now, black holes. Evidence and things unseen. Black holes have been a phenomenon in our universe. Massive objects of gravitational pull light cannot escape. In 1783, British scientist John Mitchell posited an idea of a dark star. Solar gravity is so strong that even light cannot escape. Even animated on the surface, a dark star, even putting of solar gravity, such as a star to be invisible. But it is possible that massive light that cannot escape. Now, bending space and time. Before Einstein, scientists thought that gravity had force to pull things through space. Einstein supposed that gravity is not all force at all, but rather a bending of space and time. But what does this mean, a bend space and time? In essence, this means that gravity, and towards a velocity of empty space and matter, and just goes along for the ride. We can illustrate this with an analogy: sailboat on the lake. The surface of the water represents empty space. The boats represent matter. The wind represents external force on these boats, which drives them through the water. Now, what makes matter move? Well, one, external forces move matter through space. Just the wind moves the sailboat through the water, but we want to move through space. In reality, gravity moves space itself, pulling matter with it. Just as a sailboat moves along a flowing river, and there is no external forces, space itself moves matter. Before Einstein, gravity was ought to be like a wind, external force acting on matter. But Einstein suggested that gravity is effect not on matter but on space itself. In our analogy, this means the water itself flowing as on a river. And okay, as the boat's just along for the ride, and they have moved. There is no wind because water itself carries them along. Our analogy, photons, particles are light and considered by fast motorboats. And although they're stuck open to the speed, okay, it's reasons below. Okay, I'm going to space and a motorboat. Okay, motorbikes travels the same speed, but the path of the motorboats affected the motorboats moving, and this with the gravity bends the path of light because light travels through space, and space is moved by gravity. We don't notice the effect of gravity bending light here on Earth because Earth's gravity is very weak compared to the speed of light. but the bending of light by gravity has been detected in space. How a black hole works. Gravity is so strong near a black hole that pulls space inward faster than light can travel away. And there is no point in which light stops, because it's traveling outward at the same speed and it's pulled inward, called the event horizon. This effect is more several variations of Einstein physics, of physics of confidence of the gravity, bend space at the time as Einstein claimed. Since space itself is pulled by gravity, modern physics includes that it is indeed possible that the gravitational field is so strong that spaces would be moving so fast that the light itself cannot escape. And in a sense, nothing can travel through space faster than light. Nothing would be able to escape such a powerful gravitational field. This is a black hole. In term coined by physicist John Wheeler in 1967. Although there's many of me seen counterintuitive, black holes are a real phenomenon. Since space itself is pulled by gravity, modern is its as possible a gravitational field so strong that light cannot escape. This is a black hole. Black holes are dark stars. Black holes are similar to many spectrums to dark stars, according by Mitchell. But there have been some differences because understanding of physics have improved at Mitchell's time. Example, unlike Mitchell's condition, actual mass of a black hole is ending no size at all. That's because the gravity is so strong that all mass of a star becomes crushed at the point of singularity. So the substance of a black hole in the singularity. To illustrate physics of a black hole, let's return to our lake analogy. Imagine we pull out of a giant cork in the middle of the lake, and the water begins to drain. Water draining the edge of the lake and becomes unaffected. While water near the center of gravity moves toward the drain. The drain represents the domestic object in the singularity. But at the same distance of the drain, water would be moving the same speed of motorboats. The center of works of light. In other words, the radius of the water supplies in space, moving at the speed of light. Which is the note of the symbol. In the black hole, the sentence of called the Schwarzschild radius. This is a place of while space is falling falling into the black hole at the speed of light. Imagine the motorboat trying to escape aiming from the train. It would be stationary because it moves at the same speed from the water, and the water is flowing toward the drain. Likewise, the light is aimed away from the black hole. We stationary of Schwarzschild radius. And it would be like salmon trying to swim upstream, but not making any headway. Objects are further away, such as radius, and does not get pulled in. They could object a black hole, just as planets orbit the sun. Yeah, but the effects of gravity pulling in space diminish the instance of the singularity, just as water being pulled toward the drain and minimal far from the drain. Now the event horizon. The region of corresponding to a radius of event horizon. It is a horizon because because you can't see past it. You would never see any events that happen inside of it. Since the light would never reach you. When astronomers talk about the size of a black hole, they are referring to the event horizon. They call it actual mass of a black hole, the singularity. It's actually no size at all. The size of the event horizon depends on the mass of the singularity. The event horizon is the point of no return for a black hole. Inside the event horizon, space is being pulled toward the singularity faster than the speed of light. Yes, physics can allow this. Linear matter or energy can move through faster than the speed of light. There is no known restriction how fast space itself can move. There is nothing can move through space faster than light. Anything inside the event horizon can be pulled toward the singularity and crushed into it, and there is no escape. Even lights can be pulled backwards into singularity. Another strange consequence of being of a strong gravitational field and actually open a black hole at a distance of 1.5 times a short-wave radius, and in distance light, and even just the right direction, would be influenced so strongly by the black hole's gravity. That will circle around the black hole indefinitely. Finding black holes. Okay, the giant elliptical gravity at M887 is located 50 million light years away in the constellation Virgo. The object in the center of M87 is a description of a black hole. A black hole is believed to be an engine amidst a brilliant of high-speed electrons. Diagonal line across image. Full courtesy of NASA. But if black holes are invisible, how could ever find one? Mitchell suggested looking for dark stars in binary star systems. A binary star consists of two stars orbiting each other. Mitchell reasoned in some binary star systems, one of the two stars that would be a dark star. Therefore, we should expect some visible orbiting around visible companion. What we do? One example of Cygnus X1. Here, a blue supergiant star orbits around the unseen companion. The stated mass of the invisible object indicates that it is indeed a black hole. Many similar cases have been found, but any other ways to detect black holes as well. For instance, material falling into a black hole can heat up and give off X-rays, other forms of radiation, and it reaches the event horizon. Some black holes have mass comparable to a star, and these massive black holes can be crushed at cores, explode stars, and other black holes are much more massive. These can be formed by the center of galaxies, even for our own. Black holes provide observable confirmation of Einstein's theory of black hole of general relativity, such as physics of basic of universe cosmologies, which allow light of distant galaxies or of years of less. Scientific discoveries such as black holes and understanding and give a glimpse into the lights of thoughts of the infinite God. Alright, now what is dark matter? Astronomers have discovered that galaxies rotate faster and would have compressed only observable objects, such as stars, gas, and dust. In other words, a visible mass of the most galaxies does not provide gravitational attraction for the amount of missions we observe. This scientist that galaxies contain invisible sorts of mass called dark matter. Dark matter is any non-visible evidence the substance detected by only the conditional influence by other invisible objects. Most astrophysicists currently believe that there is much more dark matter in the universe than visible matter. Some physicists believe that dark matter is composed of ordinary matter, but such matter can also be enough for radiation to detect. For example, planets of other large objects do not radiate energy and reflect light from nearby stars, and they contain unclassified dark matter. Black holes are one example of this category, however. More commonly believe that the most dark matter, composed by exotic and yet undiscovered particles at the universe, that is called the magnetic dark matter because ordinary atoms would not be protons, neutrons, which are barons. Now, some scientists suggest that alternative to dark matter, for example, that it may be flaws of physics and scientific understanding this by the creative models, if even if this model is correct. There's maybe a black hole in the universe that is also demonstrating to a Big Bang model, such as computer quality of dark matter. However, most creation models of cosmology would work either way. The exoticity of radiation gravity as equations eventual gravity visual activity, but it does the expansion of the judge quality of the universe. So this is okay. It's age by covered the Big Bang black holes, exploration, and much more. Okay, this is about so this video right here about black holes. So. Now, how should I get saved? Okay, the point of evolution is to damn souls to hell. To go to heaven is to believe on our Lord Jesus Christ. Salvation is by faith alone, the grace of Jesus Christ alone. And once you know you're saved by easy belief in the truth, meaning you can't lose your salvation forever. But easy belief says that salvation is you is believe in Jesus Christ for salvation. And our next video is that what does about say about white holes? Well, I'll talk about that next video. Well, I'll talk about white holes next video. You know, white holes? Yeah. Because I want to get into that too. And I know there's many atheists that like to talk about white holes. Well, I'll get to that next video. And you have to go right now. So thank you for watching this video. Be sure to bye.